not what I wanted to do. Doesn't want to bring it in. Okay. Want to go over some examples so that, in the future, people take Calculus 2, they got these things. And then it is free. There's no charge. Is that a good thing, by the way? Just curious. Is it? Shh, don't tell anybody. Well, shh, don't tell anybody the secret here. We had some department members. They were paid money to develop resources for the last year and a half. You know what happened? They didn't do the work. How'd you know? I told you already. They didn't do the work. So the school called me and said, Daniel, like the college president and the Senate president, they were so angry with these rookies. They're rookies. I think they're worse than rookies. They're not even B team. They're like C team, D team. They didn't do the work, but they got paid. I said, can we use your resources? I said, yes. Go ahead. It's free. You know what they did yesterday? They tried to meet with some publishers so that they can have students pay for those resources. Shameful. I chastised them for that because the school asked me to do it. I said, could you talk to these rookies? I said, you know what it's like to talk to rookies? So I'll always remember this story for the rest of my life. I'll be on my deathbed. I'll go, oh my God. Anyway, this is what I'm saying. This is what I've said to them. You guys should develop your own resources. Make them free. Do the heavy lifting. Do the work. That's just my opinion. Did they listen? Nope. Because it's easier to have you pay for these computer program blah, blah, blahs from the publishers that already did the work, but you pay for it. They got paid and did not do the work. All righty. Let's get to work. What is this? Good. AN. You guys okay with that? And I don't like that I can't see this AN. Okay. Then I'm going to use this phrase. This series, BL, behaves like what? 2 over what? N cubed. Are you guys okay with this? Two over N cubed. Okay. This here is going to be the what? Bn. So you're going to look now at the limit of what? An to Bn. And what does that equal? 2 over N cubed plus 4 over. Okay, what are you going to use here? Use your algebra, ladies and gentlemen. I got to use purple for algebra. Okay, like I said, it's really using algebra here. By algebra, what do you guys know is going to happen? N cubed over what? I think it's plus 4. Is that right? All right. Now go back to calculus 1 or 2. Should we do this by calculus 2? You said, I took calculus 2. I already did calculus 1. Okay, well then you could use calculus 1 here to find that limit. But by calculus 2, doesn't that give you what? Infinity over infinity? What is this? The number what? Isn't this 1? That's the limit of the constant what? 1. What is that limit going to equal? 1. There is your C value. It's finite. Is it positive? The answer is yes. So the first part of the limit comparison test is satisfied. Okay? It's a finite value that's positive, so it's fine. It's satisfied. All right. Okay. Then either both of these series what? Converge. Are they both what? Diverge. Now you're going to go straight to this series right here. Okay? So let me go and say to you guys, how do we look at this? Well, pull out your what? Pull out the constant 2. And tell me something about the series 1 over n cubed here. Okay? Does anybody know anything about that series? Say yes. What did I send you guys yesterday? Or what did we talk about yesterday? Yes, this is a convergent what? P series. You see how I said we're going to use that information? So I sent you that proof yesterday. What is your value for P? P is what? What does P have to be in order to be a convergent P series? Greater than 1. Outstanding. So this is finite. And 2 times a finite number is what? Is a finite number. That's what I mean by that. That's why you can factor out this 2. Because 2 times a finite is finite. What does that mean? This series AN is also what? Finite. It converges. And we say converges by what? The limit comparison test. There it is, ladies and gentlemen. Easy peasy, lemon squeezy. So then in the future, as all those students, maybe they don't have to buy those expensive resources. They could just watch these videos. There it is. That's it. So I'll be working on more resources, Calculus 1, Calculus 2, and they'll be free. Okay. All right, let's try this one out here, ladies and gentlemen. See what this one's like here, okay? This is going to be our AN. The question is, what does this series behave like? Now, you might say, I don't see any constant term. And I'll say you're right. There is no constant term here. But we're going to have to eliminate a term, get rid of a term here. One term is more dominating than the other. Which term do you think is more dominating to this series? Here's what I'm going to say. Is n more dominating or the square root of n more dominating? N is more dominating. The variable with the highest power. So what that means is n to the first is more dominating than the square root of n. So here's what you guys want to do. Get rid of what? Square root of n. If you get rid of the square root of n and keep the more dominating term, which is green here, that's what you do. Okay? And then again, what is this called? That's your Bn. All right. Now, let's look at this. The limit of an over bn is the limit of what? What is this the limit of? 1 over n minus the square root of n over 1 over n. Do the algebra again. We get what? N over n minus the square root of n. Okay? Does anybody know what do you do here now? You could go back to calculus 1. What do I mean by that? Divide every term by the variable with the highest power in the denominator. That's the limit of what? 1 over 1 minus 1 over the square root of n. Okay? By properties of limits, 1 minus the limit, and that's the square root of n. What does that equal? Isn't that 0? Okay, that's 0. So this is going to equal, ladies and gentlemen, 1 over 1 minus 0, which again is 1. There's your C value. It's positive and what? Bless you. Positive and finite. Is that right? Now, what does that mean? Either both of these series converge or they what? They diverge. You guys with me on that one? What do you guys know about this series? Anybody here yesterday? What's the name of the series? Nope. 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 Harmonic. I see what you did mentally, yes. It's the very famous harmonic series. What do you guys know about the harmonic series? Diverges. Remember we did the integral test? Yeah, I sent you guys that stuff. So anyway, this series also what? Diverges by the limit comparison test, LCT. LCT, ladies and gentlemen, diverges by the limit comparison test. Okay, so, so notice this. What came into play? You got to know about the geometric series. That was the first example. The second example, you got to know about the P series. Third example, you got to know about the harmonic series. And there you guys go. Those are like the bread and butter of things we've worked on. And then we also worked on tests for divergence. That'll come in too eventually. So that's like the 4 main pillars of what you're looking at. And then you had telescoping series. That you're not going to do telescoping series here with this section. Limit comparison test, it's pretty much geometric series, P series, harmonic series, and that's just from my memory. And those are all things that we covered and had extra work on to send you guys. That's how that works. But, some students, if you ask around, they say, oh my God, this chapter is the hardest chapter. Well, some of my students have told me they thought it was the easiest chapter. Don't do this the night before a test. If you try to do it the night before, what's going to happen? You're going to hate your life. Have you done that before? I mean, some students. I've taught this course for years. What I have seen over the years, I can tell you guys stories all day long. What I have seen has just been sad. There's students who they say, this is at the bottom of my to-do list. So they'll focus on everything else in their life. They put it as a priority because those are the things they enjoy. And then come test day, what happens? They're like, I didn't sleep. I was studying my biology and my chemistry, and I love that. And I put this at the very end. And what I tell them is, You guys did everything wrong. You did it backwards. And if you do it backwards, you're going to get backwards results. Seen that story over and over again, you know, because they want to keep the math at the end. I kept the math in the beginning as a priority. I'll tell you another quick story about this. I was talking to somebody about it yesterday. When I took physics here, the first physics class I took was taken at the same time I took calculus, and I had no clue what they were talking about because they were talking about derivatives before I even learned a derivative. I hated that. So I dropped the class. So what I ended up doing is I took all my calculus courses eventually, calculus 1, 2, and 3, linear algebra and differential equations. And then when I transferred, that's when I took my first physics course. Do you know what grade I got in that class? Physics 1. I got an A, but I got more than an A. I would get 100% of the points. I think the lowest score I got was a 98% in my physics classes. You know what the class average was? 30%. They thought I was a genius, and they wanted me to change my major to physics. Now, you know what the truth was? I wasn't a genius. I just completed my math. So much so that I could derive the equations with the instructor as the instructor wrote things down and lectured. This was taking physics at a university. This wasn't, here on this campus or any other local community college. At a university, 100%. So I learned, complete the math before you even try that. That's what I did. I learned that how they do things is backwards. Letting me take physics 1 as I took calculus 1 was not the right thing to do. So when I got hired here, I got them to change that to make calculus 1 a prereq. I still think that's not enough. And they admitted to me, yeah, you're probably right. We should do it the way you did it, but if we did that, nobody would take the classes. All right, what's the lesson? Make your math a priority. It might be too late since we're at the end of the semester. Make it a priority. And trust me on that one, if you do, everything else will be easier. Don't do it backwards where you do the chemistry and the life biology and all the things you really care about and neglect the math. Math is the language and the key. And it'll change your life because it changed my life, in a way that I could have never imagined. So here, again, this is AN, okay? This is AN. What does this series behave like? What do you guys want to remove? The constant 4, okay? So we're going to say this behaves like what? 3n over 2n. Do you guys happen to know, by the way, what is that really going to be? It's 3/2 to the nth power. This is a geometric series, isn't it? And in fact, it's a divergent geometric series, just to kind of throw that out there. But before we get there, call this what? Bn. Okay, so when you take the limit now of the ratio an to bn, 4 plus 3 to the n over 2 to the n over 3 to the n over 2 to the n. Do that algebra. Four plus 3 to the n over 2 to the n. This will be times what? 2 to the n over 3 to the n. Okay, you guys okay with that? All right, now. So here's the deal. We're going to say this. This is going to be 4 now. Is it 4? Yeah, 4 times what? 2 to the n plus 6 to the n over 6 to the n. So I guess we're still doing some algebra. Okay? Yeah, did I distribute? Okay, you see my point? We distributed here. And what else did I use? Properties of what? Exponents. Meaning, yeah, let's take a look. I guess I'll have to do it this way for you guys can see this. What's a to the n times b to the n? Do you guys know what that is? A times b to the n by beginning algebra. Now, at this point, you might say, well, what else am I going to do? Go back to either Calculus 1 or Calculus 2. Divide by the variable with the highest power in the denominator. You say, well, what is that going to be? Well, there's only one term there, so 6 over n, 6 over n, 6 over n. So you get the limit now of 4 times 1/3 to the n plus 1 over what? 1. Double check to see if I'm okay. Yeah, I think I'm fine. Properties of limits. 4. Limit n goes to infinity. 1/3 to the n plus 1 over 1. What's this limit going to be? Isn't that limit 0? Sure is. What do you end up with here? It's going to be 4 times 0 plus 1 over 1. That's going to be just 1. So guess what? This is my C. It is greater than what? 0. Here's that C now. What do we know? Both of these series, what? Converge or diverge. So let's see. This is a divergent what? Metric series. You're going to find that R here will be what? 3/2. You guys remember what it meant to diverge? If the absolute, well, what does it mean to converge? If the absolute value of R is less than 1, well, guess what? That's not happening. So because the absolute value of 3/2 is bigger than 1, that means you have a what again? A divergent geometric series. What does that mean over here? Diverges as well. Okay? And that's really how you handle this limit comparison test. You're going to see a lot of different, well, I want to say a lot of different permutations. Like even this one, you know, here's my AN. Let me show you guys what I mean here. This one behaves like, you know what you can do with this one? You could get rid of the non-dominating terms, like the constants. Start with the constants. You got to get rid of both constants here. You say, does that give me n squared over what? 3n to the 4th? It does. Do you guys know what this is going to be? Do you guys know what this behaves like? This is my AN, though. Okay, this behaves like, I just want to kind of remind you guys. I'm sorry, BN. Anybody recognize this kind of series over here? P-series. A convergent P-series, isn't it? All right, but what do you have to really show, though? You got to look, yeah, if the limit. So, yes, you got to take the limit of what? AN to BN. And then that limit's going to be n squared minus 1 over 3n plus 4 plus 1 over n squared over what? Well, this is really going to be 1 over 3n squared, right? It's going to simplify to 1 over what? 3n squared. So that's going to be the limit now. N squared minus 1 over 3n to the fourth plus 1 times 3n squared. Limit. 3n to the fourth minus what? 3n squared over 3n to the fourth plus 1 now. Okay? But and as ugly as this looks, it's a calculus 1 question or calculus 2. You could use L'Hopital's rule here. Well, let's do it by calculus 1. N to the fourth power. Okay. Divide every term by the highest power of the variable in the denominator. Okay. Three minus 3 over n squared over 3 plus 1 over n to the fourth. Anybody know what this limit's going to be? 0. Well, no, it's not going to be 0. It's 3 over 3. I mean, what's going to happen is these limits will go to 0. Is that right? Yeah. Which means you got 3 over 3, which is 1. Again, C is greater than 0. This is finite, and it's bigger than your 0. So, ladies and gentlemen, what do we know? This is a convergent P-series. P is what number? 2. Any value bigger than 1 means it converges. Well, if that series is finite, 1/3 times finite is finite. And that means this is also what? Finite. You got convergence here as well. And we say convergence by what? By the limit comparison test. So, you know, you guys had about 5 examples there so far of some of these kinds of things. This one, I can tell you, is going to be the harmonic series. You know, I can do these all day. So number 5. So what I might do again, of course, what do you guys think I might do? Give you some extra examples by video. And I hope you guys appreciate that. But you can start working on some of those homework questions using these ideas. And remember, you're probably going to end up with a harmonic series to compare, or a geometric series, or a P-series. Okay, those 3. And that's what I centered this lecture on with all these examples. So I can do some more later when I get home, later tonight. I'll send them to you guys, but not too bad. Okay, this is all just algebra and limits. All right. We'll see you guys later. Take care. Hope you guys are all back tomorrow. All right. So we're going to start question number 5 here. And so we're going to start by eliminating the constant 3 and say that this series behaves like the series of 1 over 2n. We remove the non-dominating term now. And So we have the series here, AN. And we have the BN now. All right. So by the limit comparison test, we're going to have to look at the limit of the ratio AN to BN. What that's going to be is 1 over 2n plus 3 over 1 over 2n. Here is where we'll do some algebra. Meaning, we get the limit now, 1 over 2n plus 3 times 2n over 1, which gives us the limit of 2n over 2n plus 3 as n goes to infinity now. Okay. We could use Calculus 1 or Calculus 2. So by now, we've been using Calculus 1 for the most part, meaning divide by. We can divide by the variable to the highest power in the denominator. So let me do this again here. Meaning we can divide by 2n. That's not an issue, but I'm going to try to be consistent here. N, N, and n, so that this limit now is 2 over 2 plus 3 over n. So this is as n goes to infinity. So by properties of our limits now, we get 2 over 2 plus 3, limit n goes to infinity, 1 over n. And now this limit is 0. So we get 2 over 2 plus 3 times 0, or simply 2 over 2 equals to 1. All right. Here's the constant. Here's that c, and that c is in fact positive. So what that means now is by the limit comparison test, either both of these series converge or they diverge. So let's take a closer look at this behaves like series to determine whether this series actually converges or diverges. Now I'm going to pull out the 1/2 constant by properties of series here. You got 1 over n, and we know this particular series diverges. This is the divergent harmonic series, the very famous harmonic series. So 1/2 times infinity is infinity. So that means both of the series diverge. So we're going to say this equals infinity, which means diverges. I want to say it diverges by the limit comparison test now. So this is how we look at this particular problem, number 5. Okay. Number 6. We're going to remove the non-dominating terms from both the numerator and the denominator here. 4 to the n and 6 to the n really dominate this series more than just the variable n. So this series behaves like a series from 1 to infinity, 4 to the n over 6 to the n. Okay? Now, just doing a little algebra on this. Properties of exponents. This is going to be 4/6 to the n. Okay. We have an here. And over here, is going to be the Bn. So we'll look at the limit now of the ratio An to Bn, which is the limit of n plus 4 to the n over n plus 6 to the n. And I guess let's divide by 4 to the n over 6 to the n. So we're going to do some algebra over here. And what that means is we take the limit now of n plus 4 to the n over n plus 6 to the n times now 6 to the n over 4 to the n here. Okay. So we get the limit now by distributing n plus, well, let's make sure, n times 6 to the n plus 4 to the n times 6 to the n over n times 4 to the n plus another 4 to the n times 6 to the n. You got to look at this limit. But before we do that, let's simplify using some algebra, meaning this is 24 to the n. 24 to the n. So we have the limit, n goes to infinity, n times 6 to the n plus 24 to the n over n times 4 to the n plus 24 to the n. That's a little funny there. Okay. Now, what we're going to do again is essentially a calculus 1 move. Even though we say we divide by the variable with the highest power in the denominator, this isn't really the case here because you're not looking at polynomials. But we're going to divide by every term by that 24 to the nth power here. Okay. 6 to the n divided by 24 to the n. Let me put that in red. Plus 24 to the n over 24 to the n times 4 to the n divided by that 24 to the n plus 24 to the n divided by 24 to the n. So let's see what we get when we simplify here. The limit, n goes to infinity, we get n over 4 to the n plus 1 now over n over 6 to the n plus 1. Okay. Now, by properties of limits, what you're going to end up getting is the following. So let me get this here for you guys so you can see what's going on. Properties of limits. limit of n over 4 to the n plus the limit of 1 over that limit of n over 6 to the n plus the limit of 1. This is as n goes to infinity. Essentially, we want to know what both of these particular limits go to. Is what's happening here. All right. So I want to note here that we're going to look at the limit now as n goes to infinity, n over 4 to the n. So what we know here is we're going to get infinity over infinity, an indeterminate quotient here. All right. So we're going to have to apply now L'Hopital's rule. So by L'Hopital's rule, we know we got to take the derivative now. And let me do this here. I'm going to have to change the variable to x. So I'm going to change the color because in order to apply L'Hopital's rule, this is defined over a real variable x, not having the domain being natural numbers. All right. So we're going to have to differentiate both the numerator and the denominator. Now, if you guys recall here from Calculus 2, now using L'Hopital's rule, this will be the limit as x goes to infinity of 1 over the derivative of 4 to the x power, which will be 4 to the x natural log of 4. So this means that the limit's now going to be, since the variable here is going to infinity, natural log 4 is a constant, this limit equals 0. So that's saying that the limit now here is also 0. So we have this limit being 0, this limit being 0, and we get 0 plus 1 over 0 plus 1, 1 over 1. The limit again is 1. There's your c, and c is a positive number. So what this is saying here, that both of these series converge or diverge. Now, let's take a closer look at what this series actually is. Okay, because we actually notated that this is 4 over 6 to the nth power, which is actually 2/3 to the nth power from 1 to infinity, 1 to infinity. We're out of space here. But I want you to notice that what you're looking at is a convergent geometric series. And that's because your R will be 2/3, and the absolute value of R, which is the absolute value of 2/3, is less than, which equals 2/3, which is less than 1. So that means this original series in number 6 also converges. We'll say is less than infinity. The series converges by the limit comparison test. All right, number 6. Number 7 now. All right, number 7 here. Let's take a look here. Okay. There we go. Weird. This here is our AN. We're going to remove the constants now, so that this series behaves like a series that goes from 1 to infinity, n over n cubed, by removing those two constants. What that means, by using some algebra, that the series is 1 over n squared. All right. So that we can actually use either. Well, I'm going to use the original here, AN. It might make our algebra easier. Not sure. This is your b to the n. So we need to look at the limit now of the ratio AN to BN, which is a limit of n plus 2 over, let's see what's there, n plus 1 cube divided by n over n cube here. We're going to have to do some algebra now. So this is going to be the limit now, n plus 2 over n plus 1 cube times n cubed over n. The limit, n plus 2 times n cubed over n plus 1 cube times n. So if we do just some simplification here of some algebra, I guess we're going to get this squared term. We get the limit now of n squared n plus 2 over n plus 1 cubed now. So one thing we can do is just simply multiply. There's a few things. Well, we can distribute, I guess, and then expand the cube there. We'll get n cubed plus 2n squared over n plus 1, n plus 1, n plus 1. Just doing a little bit of algebra. So the algebra down here should give you n squared
plus 2n plus 1, but we have to multiply that by n plus 1. So we get n cubed plus 2n squared plus n squared plus 2n plus 1, which gives you n cubed plus 3n squared plus 3n plus 1 by expanding the n plus 1 cube here using algebra. All right. We need the limit here. Use calculus 1. Divide every term by the variable with the highest power in the denominator, which you end up getting is the limit now of 1 plus 2 over n over 1 plus 3 over n plus 3 over n squared plus 1 over n cubed. So, ladies and gentlemen, when we apply the limit as n goes to infinity, this term will go to 0. This term goes to 0, goes to 0, goes to 0. We're left really with 1 plus 0 over 1 plus 3 zeros, and this is 1 over 1, and that equals 1. Greater than C. It's positive. Is that C value? It's positive. So we got to remember that both of these series will converge or diverge, because this particular series, the BN series here, is a convergent P series where P equals 2. It's a convergent P series. What that means is this particular series is also convergent. So we have convergence by the limit comparison test. Number 7. All right. Number 8. All righty. So for this particular series, this will be my AN. However, we're going to remove the non-dominating terms here. Well, the constant and the n's. We're just going to work with the n squared over n cubed. So this particular series behaves like 1 to infinity n squared over n cubed, which is really going to be 1 over n. So AN now again in blue and BN over here. All right. The limit of the ratio AN to BN is that limit of n squared minus 5n over n cubed plus n plus 1 divided by 1 over n. You're going to use algebra here. Every time I get that purple highlighter out, you guys know we use algebra. The limit n squared minus 5n over n cubed plus n plus 1, that's going to be times n over 1, which means now we get the limit of n cubed minus 5n squared over really just n cubed plus n plus 1 because we're distributing here and to the numerator. So yet again, you get a Calculus 1 question where we divide every term by the variable with the highest power in the denominator now. Yet again, so we get the limit now 1 minus 5 over n, 1 plus 1 over n squared plus 1 over n cube. All right, this is as n goes to infinity. So now, as you take those limits, this goes to 0, goes to 0, goes to 0. You are left again, really eventually with 1 over 1, where this limit is 1, it's positive. This is greater than 0. This is that C value. It's finite and positive. So what that means is both the series will converge or diverge. Now, what we know is that this is the very famous divergent harmonic series. It's a harmonic series, and that series diverges, equals infinity. What that means is this series also equals infinity. Diverges by the limit comparison test. Okay? They both diverge by the limit comparison test. All right. Number 9. Here's R, A-N. What we're going to do here is remove the constant, and this series behaves like one over n square root of n squared, which simplifies to not 1 but 2, 1 over n times n, or we can simply say 1 over n squared. So this is going to be our Bn. All right. We're going to have to look at the limit now of an over bn, which is the limit of, I might need more space, one over n square root of n squared minus 1 over 1 over n squared here. We're going to use some algebra here. Limit 1 over n square root of n squared minus 1 times n squared, which is going to be the limit now of really n over the square root of n squared minus 1 here. Okay. Okay. We're going to have to apply the limit. And a couple of things to observe. This will give you infinity over infinity. And you could try to use Calculus 2 and L'Hopital's rule. But I'm going to do sort of this dividing both terms by the variable to the highest power in the denominator. Now, believe it or not, you look at this and you say, well, it must be n squared. And the answer is no. You're going to divide by n. And you say, why? Because you really have the square root of n squared there, ladies and gentlemen, which is n. Now, I can write this a few ways here. I'm going to say this. N is the square root of n squared here. So, the limit now, as n goes to infinity, the numerator is 1. The denominator is n squared minus 1 divided by the square root of n squared. So when we start to use the algebra in the denominator now, that's the square root of n squared minus 1 over n squared by properties of radicals, which gives us n squared over n squared minus 1 over n squared. In the denominator, I got 1 over, well, the square root of 1 minus 1 over n squared is what I have. So take a look at this. This is using algebra. That's the limit. N goes to infinity. 1 over square root 1 minus 1 over n squared. Now, by properties of limits, I get 1 over square root of 1 minus the limit. N goes to infinity. 1 over n squared. Now, this goes to 0, which means you have 1 over the square root of 1 minus 0, 1 over the square root of 1, 1 over 1. This limit equals 1, which is a positive number now. All right. So what that means is by the limit comparison test, both of these series either converge or they diverge. Now, this series is a convergent P series. What is P here? P is 2. It's a convergent P series. So what this means is both the series converge. So this is convergence. And we're going to end up saying we converge by the limit comparison test. Convergence. Both series converge.